Okay, welcome. Today we're going to look at a little programming problem I've noticed going around. It's a fairly old problem called FizzBuzz. Apparently, many companies give it to programmers that they're interviewing. What FizzBuzz? The problem statement is simple. Print out the numbers 1 to 100, replacing multiples of 3 with the text fizz, and multiples of 5 with the text buzz. Well, let's have a go at doing this in Haskell. Let's see how far we can go. Okay, so the first thing we're going to do is we're going to just deal with this part of the problem statement. Let's print out the numbers 1 to 100. So that's easy. We just do main equal what we count is defined by, we do map and then print, and then we just do a list of 1 to 100. Okay, so let's save that. I will do that, and then I will just load that up, and I'm going to do main. There, we get 1 to 100, not a problem. Okay, so we've done that. Now the next thing is we need to replace multiples of 3 with text fizz, multiples of 5 with text buzz. So how are we going to go about that? Well, I think the best way to go about this is to remember what Sir Anthony Hoare taught us, that the program structure should reflect the type structure. So what we're going to do is, rather than see this as what we're going to do as printing out a list of numbers, we're going to change this into a program of printing out a list of what I'm going to call fumbers. Okay? Oops, fumbers. So what's a fumber? Well, a fumber is either just a number, which we'll just use the int type, or it's a message, which will represent using a string. Okay, so if I just do deriving show, that will allow us to print fumbers. So the next thing is, I'm now going to change our program. Instead of printing out numbers 1 to 100, it's going to print out the fumbers 1 to 100. And the way we do that is very simple. We are going to, before we print out the numbers, we convert them to fumbers, which we can do using the num function here. Yep, because num takes an int and gives you back a fumber. So we'll just do this. First, we'll basically convert every number to fumber, and then we'll print out every fumber. Alright, so if I build that, and then there we go. So we got fumber. So instead of 1 to 1, it's saying num, yeah, num 1, num 1, num 2. Yeah, no problem. Okay, now we might say, well, wouldn't we rather have it if, well, actually, we'll clean that up at the end so that it just says, it just, 1, 2. In fact, let's do that now, because we don't want that num there, really. That's just, we would like it to be, as it was before. If we go up here, we see we just want to see the number alone. So what we'll do is, instead of doing deriving show, we will actually show instance show fumber where, and then show num n, we should just do show n, and show message ss should just give us ss, just gives the string, because it's just a string. Okay, let's do that, we reload, and there, now we're back to we're still showing fumbers, but we don't have that num constructed there anymore. Okay, that's good. Now we can go on to the next stage. The next stage is we want to replace multiples of 3 with the text fizz and multiples of 5 with the text buzz. So let's tackle multiples of 3 first. What we'll do is we'll define a function. We'll call it mul3. It takes an integer and then it gives us back a fumble. Now mul3 is pretty simple to define. Mul3 n equals if n mod 3 equals 0. So that's if n is a multiple of 3, then we want to print out the message fizz, else we will just return the number again, num n. Okay, and then of course to do multiples of 5 is, but you know what, let's just stop there. And what we'll do is, just to test that out, instead of num, we'll now replace that with mul3. So what should happen is when our numbers get printed out, any multiples of 3 should be fizz, otherwise you just see the number. Okay, so I'm going to build that, and then I'm going to reload, and we see we're getting fizz everywhere. So that's 3, 6, 9, 12. Yep, that's what it's doing. So every multiple of 3 it gives us fizz. Fantastic. Now the next stage, multiples of 5. Well, that's pretty easy. We'll just do another function, mul5, and mul5 n equals if n mod 3, so n mod 5 equals 0, then message buzz, else, again we just do the num. Alright, and if we change this to mul5, alright, then we build, and then we reload, and now we see all the multiples of 5. We've got 100 there, that's multiple of 5, 95, 85, I'm sorry, 90, 85, yep, all the multiples of 5 buzz. That's great, right? So we can do multiples of 3 separately, and we can do multiples of 5 separately. But what we're asked to do is multiples of 3 and 5 together. So how do we do that? Well, that's simple. What we'll do is we'll define a function called test. Let's go test for want of a better word. And test n equals, it will do multiples of 3 to n, and then I'm going to define an operator, multiples of 5. So it will combine our tests, basically. Combine them, yes, it'll do, so test n will do multiple of 3n, multiple of 5n. Okay, and then we can just change that to test. So that's great. All we have to do then is define this operator. So let's do that now. We have, I wonder if I can just get away with just this. I'm just going to see if I can just get away with that. Yeah. It takes a fumba and another fumba, and it gives you another fumba. Okay. So there's a number of cases. The first case is the number is neither a multiple of 3 nor a multiple of 5. If it's not a multiple of 3, then mul3 will have given us num n. Okay, so num n. And if it's not a multiple of 5, then the result of applying a multiple of 5 will have been num n as well. So we'll have this. And if that's the case, then we just have num n. Okay. Now, the next case is it's a multiple of 5. Sorry, it's a multiple of 3, but it's not a multiple of 5. So in this case, we will have, it's a multiple of 3, so we're going to have the result of mul3n will have been fizz, message fizz, oops, message fizz, whereas the result of mul5 n, because it's not a multiple of 5, will just be num n again. Okay, in that case, since it's a multiple of 3, we want fizz to be printed out, so the result would be fizz. Alright, now the next case is not a multiple of 3, but it is a multiple of 5. Now, since it's not a multiple of 3, mul3n will give us num n, and mul5, because it is a multiple of 5, will give us message buzz. Okay, and if that's the case, well, the result is we want message buzz. Alright, and the final case, simple. It's a multiple of 3, in which case we get fizz, and it's a multiple of 5, which we get buzz. Oops. What's going on here? That is multiple of 5. So what should the result be? Well, actually, it's normally put in the question, but I forgot. But what should happen is, if it's a multiple of 3 is a multiple of 5, then it should print out FizzBuzz. So in this case, we just have message FizzBuzz. Sorry about that. I should have probably put that in the, because normally they do put that in the problem statement. FizzBuzz. Fantastic. So we can change that. So now it should work. We should be done. So if I just build this, okay, and then I reload here. Oh, okay, there's another. Oh, what is saying? Conflicting definitions for num n. Oh, I see. Okay. Okay, what I'm going to do is I'm just going to do this. I'm going to use a wildcard. Let's see, that should. There we go. So because it doesn't matter what the right hand side is, but that's an interesting thing. That's a pattern matching thing. Okay. And now when we run main, so let's take a look. Let's start at the top. We've got 1, 2, 3 buzz, 4, so fizz, 4, 5 buzz, yeah. 6 is buzz, fizz is multiple of 6, multiple of 3, sorry. 9 multiple of 3 fizz, 10 multiple, yeah, and then 15, which of course is multiple of 3 and 5, we get FizzBuzz. So what's the next multiple of 3 and 5? Let's see. So we got 18, 19, 20, 21, 22, 23, 24 is a multiple of 3 and 5. No, wait a minute, not 24. Sorry. 30. Yes, multiple of 3 and 5. Aha. Okay. That's good. So, and then we get 45, which makes sense. Fantastic. So there it is. If we go all the way down. Sorry. There we go. If we go all the way down, we see 60. Yeah, multiple of 3 and 5. 70 is only multiple of 5. 75, yes. And then 90, excellent. And that's it. So 90 is the biggest one between 100. Fantastic. So there we go. That's our program. Now, an interesting addition to this program, a follow-up question, would be to say something like, okay, now change your program so that all multiples of 7 will have, say, Baz, for example. But if it's a multiple of 3 and 7, it should say FizzBuzz. If it's a multiple of 5 and 7, it should say BuzzBuzz. And if it's a multiple of 3, 5, and 7, it should be FizzBuzzBuzz. So how could we do that? Well, I'll let you think about that. And what I'll do is we'll look at a nice way to do it, because there's an obvious way to do it that is not so nice. and there's a really nice way to do it. So we'll look at that though in the next video. Until then, take care.